Now I'm entering into a new topic. The artificial activity made by man, breeding. In breeding, we are copying things we have noticed in nature. We are not inventing anything, we are just performing things that are happening in nature on their own. So, when we find an isolated population, we can impose an artificial selection on a very more intensive scale that happens in nature. For example, we can select out only the blue individuals. Or in another breeding program, we can select out only the orange ones. And then suddenly, very quickly, we get very different races. Very, very different. Because the artificial selection has led to the creation of races. Now, of course, what kind of races we get will depend on what we select for. And of course, we know that there are many races of dogs, and they can be very different. And this has been achieved by man through the process of breeding dogs. Next slide. However, the important thing is that we must keep the races separate. The moment we forget about isolation and we allow these animals to interbreed, we get mongrels. And this is something that we all know that exists, and the isolation is an essential element of any breeding program. Now, let me come to conclusions. Loss of variation, including genetic variation, results from the following factors that operate in nature. First of all, isolation. An isolated fragment of population does not have all its variability. Then inbreeding comes in. Small populations interbreed, homogenize, accidentally lose genes. This is genetic drift. Then comes natural selection. Forms unsuited to a given environment do not survive, and thus some of their genes get lost. When we come to artificial selection, the breeding is much more intensive. We'll select for some special types, enhancing the presence of some features and genes responsible for them, while eliminating others. The important thing to note is that loss of variation of genes does not give you anything new. When isolation is discontinued, we get recombination of genes and the variability returns. Some variants may be reconstituted, but nothing new results. Therefore, race formation is a process in the opposite direction to evolution, which requires new genes. Now I come to a new topic. Mutations. Let us come back to the original population that is very variable. And we have mutagenetic agents operating on this population. So what do we observe? Some mutations are destructive. They are negative mutations. We know that there are negative mutations. In fact, we fear mutations. We are trying to prevent mutations affecting the human population. We are trying to avoid radioactivity and other mutagenic agents. Because what happens? If, for example, this individual mutates and it becomes unable to live, we lose that individual from the population. If this one mutates, we lose it from the population. So what does that mean? The population is losing some individuals, but as a whole, the effect is minimal. Then we have some mutations which are neutral. There are many neutral mutations. What does a neutral mutation mean? It means that there is some change, but it has no effect on the functioning of the organism. So if this individual mutates, but there's no change in its functioning, we still have it. It's the same as it was. There's no effect on the population. What in fact is suggested when teaching evolution is that occasionally there are positive mutations. A positive mutation is a change of an individual into something completely different, something that did not exist in the population beforehand, and something which is positive in the sense that it is maintaining the population as something valuable. Now this is a postulate. This is not an observed fact, it is a postulate on which the whole theory of evolution is based. Now, are there any examples of positive mutations that we could point to?